to Belinda. Belinda is from the Department of Transport and now works in network planning. And yeah, she's got some really, really cool data visualizations, which I think she's going to present today. So Belinda, over to you.
Thank you. You need to stop sharing your screen so that I can share mine.
Yes,
Yep.
I will.
Yeah.
Figure out how to do that. There we go. All yours.
Okay. This is great. I can just pretend that there's nobody watching. Okay. No. I don't think that worked.
We can definitely see your screen.
It's fine. Yeah, all good.
You can see the main screen, not the presenter screen?
The main,
That's right.
the presenter screen. Yep.
Oh, okay.
Yeah,
I wanted to.
and the main screen.
Oh, okay, good. Great. Okay. Well, hi. Thank you for coming. I want to talk about some work that I did last year and continuing to work on. So it's about looking at public transport accessibility versus driving accessibility. And so it started. Though this is the end product. So well, it's a 1,000 point version. I've run more points, but I haven't had time to map them yet. So what it shows is this is kind of like starting at the end instead of at the start. But what it shows is the predicted public transport travel time from each dot to a dot in the middle, which is my office, 1 Spring Street. And so it takes the public transport travel time predicted by Google Maps and subtracts the driving time predicted by Google Maps in traffic. So it's not a it's not a final answer. It's not definitive, but it's a rough proof of concept, which I did to show that this was possible for my work. So a bit about me to start off with. I love data, maps, and trains, and I particularly like new railway lines. So working in the Department of Transport is probably a good spot for me to be. A little bit about my background, so mostly science and maths. I've worked a lot. I'm a lot older than I look. I spent about a decade working in accounts, but I've always been a numbers person, and so I've sort of slowly morphed from accounts to analysis to sort of programming and transport planning now. So I did move to New Zealand for 3 years, and I worked on the electrification of the Auckland railways, which was fun. And I have worked for PTV for a year in operational performance, which is lateness and cancellation stats of public transport. I did a talk about some of that work at Our Ladies a couple of years ago. That's on YouTube. And I currently work at the Department of Transport as a transport system analyst, and I've been there for a couple of years now. So my team is strategic transport network planning. Excuse me. And so what we do is we look at the transport modelling outputs that another team put together. And so we're looking at like, where are people going to be living, where are people going to be working, and what sort of trips will that generate, to look at how the network will cope with that. So we look at, where do we need to be moving more people, and from A to B, and it should be, we try to be mode agnostic. We mostly ex-Vic Roads people in my team, but strategic planning is very mode agnostic. So what I actually do is I do a lot of data interpretation for non-technical people. Planners aren't necessarily data people. So I make a lot of maps and graphs, but I now have a colleague to offload the maps onto, which is awesome. And sometimes if I'm lucky, I get to look at some operational data. So I did Spend a fair bit of last year looking at tram performance data in terms of where trams are going slowly on the network, from a year's worth of data, and that project is now being updated by the tram team. This is just a random old map because I love old maps. So if I was in strategic planning or rail planning 50 years ago, I might have been involved in this map. And you'll see that if you're from Melbourne, that we haven't got a lot of this done, but we do have, we have built the city loop, so tick. Doncaster's not going so well, but we are looking into Rowville Rail, so that's something. So yeah, plans often change. So the problem that led me to this project was came out of a meeting about getting workers to the airport, and so we were looking at, someone was saying, oh, but like people aren't going to take public transport to the airport if they work there because they tend to live in the west and they might get free parking in some cases, and it's going to be quick and direct and easy to drive, whereas the public transport options are maybe not so good. I haven't sort of looked into the detail of this, but you know, you have to consider that it's always a choice that someone makes, like whether they want to drive or whether they want to take public transport, and it will be that choice will be changed by their perception as well as the reality of how difficult it's going to be. So I guess the point that came up was that if driving is faster and more reliable, you're just not going to choose public transport. So, and I used the example of, you know, if I want to go somewhere, and so I've just pulled out an example from Google today. If I want to go and visit my sister and it's going to take me 20 minutes to drive, and I'm a big public transport person, but if it's going to take me an hour and like two trains or a train and a tram and like a whole lot of walking, I'm just like, no. So if you think that like so many people now are making their trip decisions based on whether they what they find in Google Maps. So even if Google Maps is inaccurate, it's still what people are using to make their decision if they've not done the trip before, or if, you know, the trip is sort of, yeah, what they're normally used to. So, so my colleague said, oh, if only we could get some data on, you know, what people's choices were at different points and on the map in the West if they work at the airport. And my famous last words were, oh, I can do that. So I went to a talk a few years ago that Dave Cooley did on some Google Maps API wrappers that he's put together in R, and so I knew that it was possible to automate the collection of this data. So I started my journey in this epic project. So this is the talk plan. So I have to tell you about some jargon, which I've probably already used and you probably don't know what I was saying. We're going to talk about generating origin points, which so obviously there's a whole lot of dots that you start from and you're querying going to the destination point. The API can only run 100 pairs, OD pairs per call. I'll explain that. So you need to just do some housekeeping to get that working. And then, then number 3, you have to get the data out of the nested lists. And I'm not a fan of nested lists at all. And that's going to be my week. I have to fix my code. So 4 is using Leaflet to plot the results. You're going to need to think about the data that you've got out and whether you need to take some outliers out and adjust the scale. And then there's sort of a fair bit more that this doesn't do, and what ideally you would need to do to actually use this for something. The picture here is a 1920s isochrone, which I'll explain in a minute, of how long it would take you by rail or tram to get to the city. And you can see that, sorry, I love old railway lines. You can see that the Q line's still there and they're just proposing the Glen Waverley line. So Right, so jargon. This is an empty train the other day during COVID. So PT is obviously public transport. In this case, it does include the time walking to and from stops and interchanges. PV is private vehicle or car, obviously. We have strange names for things in planning land. An OD pair is a trip between an origin and a destination location. And a centroid is the middle of a shape. So you can have population weighted centroids or employment weighted, but we're just looking at centers of shapes here. So a shapefile is a file sort of format used by GIS, software to store points, lines, and/or polygons for maps. Mode is obviously the mode of transport that you're using. Mode shift is moving from one mode to another, and I'll explain isochrones and choropleths. I hope that's not like too simple. I assume that because I say this stuff all the time, I thought I'd better explain it just in case you don't know what I'm talking about. So an isochrone, so these maps are kind of sort of isochrones, but not really. So an isochrone is like an isobar where you have pressure drawn on a map. You join up areas with the same distance, the same time taken to get somewhere. So it's sort of a time instead of a distance measure. And so this old one is from a 1954 planning scheme where they looked at putting the city loop through Lonsdale Street or whatever that is, and how that would change, how long it would take you to get to different parts of the city. So here is an isochrone that might make more sense to you. Looks at how long it would take you to drive to different places from or to different places, and with the Melbourne being the middle of Melbourne being the origin or the destination. So this is a roughly 10-minute. This is an open source, open route service map for driving. So it gives you an idea of kind of colouring by time rather than any other variable. So a choropleth is kind of similar but different. So a choropleth is where you've got a shape, so in this case, usually suburbs, where you would have data on a particular area and you colour that area based on the data. So this one was made by a colleague who loves to get into the ABS data, particularly the journey to work data. So it's worth checking out his blog. It's chartingtransport.com. So this is an early choropleth that I made. As part of this project, I tried a lot of different ways of doing the initial origin dots because I just needed to generate some, and so this is our modelling, our strategic modelling zones, and I've just taken the centre of the zone. So the problem with this is that, so I've coloured it by the answer I got in the coloured dot in the middle, and the problem is it kind of implies, because they're so uneven, it kind of implies that the data sort of stretches out further than it actually does, and you can't sort of resize it very easily because the zones are the zones and you'd have to sort of aggregate or disaggregate, and so decided not to go that way. But Leaflet can do polygons as well. So going through the talk plan, so we start off with making the points. So I decided to use a hexagonal grid to query the origins and destinations. So you need to consider, we'll see later that if you are if you end up with a point in the river, you're going to get a not very useful answer. So ideally you would start with a polygon that excluded the river, but I didn't do that. I need to do that. Curvature of the earth is another thing. It's to do with so this is an early version of the sunshine map. So you'll notice that the grid is not quite sort of even. It's a little bit longer one way than the other, and it's to do with complex mapping stuff and just the way that grid's been generated and the way that Leaflet projects it. So yeah, that annoys me a bit, but you probably wouldn't notice. So this was a first go at doing those calculations for 100 points in Sunshine before I figured out how to run more than 100 points at a time. And I've obviously put the transport networks on in the background, so you can sort of, because obviously that helps you to understand what's going on. So if you wanted to run this, it's quite easy to generate the points. All you need to do is use this code here, and so you've got a so MelbURN, Leaflet, and SP, which is a spatial package, and the picture on the right is actually they're actually points. They're not. They're just very close together. So if you zoom in, it looks a bit like that, and if you zoom in further, that's what it looks like across the CBD. Because I assume you would have an idea of what that scale is. So if you wanted to map this in Leaflet, it's very easy. It is as simple as Leaflet, add tiles, add circles, as long as your data's in the right format. But yeah, so one of the biggest problems of this project was just how to select areas that were appropriate. So you usually kind of want to look around a certain area, but you won't. The API isn't free, so you can't run thousands and thousands of points, and you want to be able to zoom in on the right spot. So initially, I thought it was quite a difficult problem, but I Googled it, and there's a simple solution. So just calculate the distance you generate your grid, calculate the distance from each point to the destination, sort by that distance, and then just take the top of the list, and that will sort of effectively fan out around your I call it origin centroid. But yeah, and you don't have to mess around with trying to select particular areas. You can do that too, but yeah, that was easier for a big network view. So this is the code that does that. So straight from Stack Exchange, and as simple. Well, I did have to alter it a little bit, but and just a sort in order to get them in the right order. So and it doesn't matter if it's not exactly the right distance. So then number two, so to actually run the queries, once you've got your origins, you need to, so I'll just open up the timer so I know if I'm taking too long. You need to set up your free trial with Google Cloud, and like I said, 100 points at a time, so you need to split them out. And so this is the code that I used to do that. So it's just a split function, and then it makes a list of data frames. And so then you need to put rearrange the data back into a format that the API can handle, which is that code. And you then can run the queries. So it's so this is the Google way, Google distance function, and so I'm just writing a function around that. So I just chuck 100 points at a time at it. I'm calling it destinations because that's what it's called in the code, but I'm only using one destination to make it easier to handle the output. You put your API key in, you tell it what mode you want to use. Obviously transit is the US word for it. And you can even request like just train or just tram or bus. So you can get quite detailed with that. And I just put a time, I just record the time so that I know what time that departure was run from if I load it later. And I put my different modes together in the same output nested list, and then because then I can pass it back. So this is how I feel about nested lists. I hadn't used lists at all before, pretty much, so that was lots of fun. So you could use a really ugly and terrible for loop, and this is definitely not what I did when I was in a hurry. You can use the Google Way accessor functions, which will make things slightly easier. I would definitely advise using functional programming, and that's what I'm going to be working on next week. And some links for some documentation. So number 4, using Leaflet to plot. So Magritte R, if you don't know it already, you will need to learn it. It's very useful, particularly for the layering, which I talk about in my previous Our Ladies talk. So you can add background tiles, points, polylines, polygons, and tooltips. So this is, if you want a blank map, you do have to show it where you want it to center on. So this is just Melbourne, obviously. I don't like the default tile set, which is OpenStreetMaps, so I just use the CartoDB Lite. And so it's as easy as just putting the URL in, and I've got in the source code, you can see there's links to, you can Google other base maps that you can use. So to add points, it's as easy as this. And you can give them a color. And you can use palettes to color them as well. If you want to put network files on in the network paths on in the background, this is where you can find them. They're publicly available. So it's probably better to download them all because they're annoying to download separately, but these are the ones that you want. And you can get the stops very easily out of GTFS, which is in my Our Ladies talk, and the slides are there. So you can also, so this is the code for adding polylines. You do need to have them in the right format, which can be a bit to get your head around. This is actually, I've actually literally reused these lines from what I was doing at PTV, so they're not up to date. So I need to do that. And they'll be a little bit smaller than the shapefile version. And you can add polygons as well. That's from a different example of where I was looking at ABS polygons, and you can do the tooltips with a label. And change the fill opacity. To add a legend, this is how you do it. And I've used our color brewer there. And this is how you do a scale bar. And so that's sort of all of the things that you need to know to make this map, apart from joining the data on to the Leaflet sort of side of things is fun. So adjusting the scale. So if you just chuck the data straight into Leaflet, things don't look that bad here. Sort of, it's mostly green and maybe a little bit of yellow, but yellow is actually kind of 40 minutes longer by public transport. So you need to just think about the scale that you're using. And this was the first go that I had at mapping 1,000 points, and I got a point in the river, and that one decided that it was going to take a while to swim out, so it made everything else look green. And you might have other, like this one goes up to like 400 minutes difference, so you might just want to remove those. So an example of how we use this data. So this was the proof of concept that I showed to the bus planning team. Now this is out of date now because they have updated the bus networks in Melton, but it kind of shows where the sort of walking to the bus kind of falls off, because when you get an NA, when Google can't find a viable PT trip, you obviously can't subtract the driving time from no viable PT option. So I like the way the grey just automatically shows you where the end of the earth is in terms of public transport land. This was with a destination of sunshine. So I'll have to update that one and see how they're going with their new bus network. So where to next? Well, I have spoken very quickly. So I've talked about bus planning, lining up arrival, not departure. So you have to use the departure time. I'm running for the same departure time for both modes because you can't do an arrival time with the driving API. And I've complained to Google about this too. So I mean, you could do it obviously through sort of figuring it out backwards, but you know, there's more coding and more there's sort of logic that you need to build in, and more calls to sort of make sure you're getting the right departure time, if that makes sense. So I believe that the Microsoft Azure Maps API does have arrival time, so I'm looking into that. So you can do arrival, you can set an arrival time for PT with the Google Maps API for transit, obviously, but you can't do it with the driving. So obviously I want to run more points and run multiple samples, because I'm just taking one sample at like departure 8 a.m. on a Wednesday morning or something, and so with the public transport timetables and, you know, how traffic changes as well, you know, you need more samples than that, depending on exactly when you're trying to measure and what you're trying to measure. So I need to do a lot of work on how I query multiple destinations and store things, because at the moment it's a relatively simple structure that can deal with what it can deal with, and it needs rethinking if I'm running more kind of layers of time or space on top of it. So I kind of touched on before, like perceived reliability and number of changes. So obviously there's a lot of things that are going to affect whether people want to take a public transport journey. So I've not, you need to do a lot more sampling and look into a lot more detail to look at that. This is just a very rough guide to maybe look, oh, this area looks bad, let's look into that further. So plotting the paths taken by these predicted trips. If you want the detail of the Google directions, so that's a separate API, which Google Way has a wrapper for as well, and Google Polylines is a separate package, which you can easily draw those lines which are encoded in a like a crazy string of numbers and letters. It's a long story. Look, read the docs. So yeah, definitely need to do more visualizations of the data. I'm not really a mapping person, and you know, I need to do things like, you need to look at, well, what's the driving time map look like, and what does the PT time look like, and but also sort of do more calculations on you know, what you know, what is the best objective function for, you know, deciding whether someone wants to take that trip by a certain mode or another. Obviously that kind of changes with each person and how they value time and whether they have a car or not. So to some extent, I think it's better to not go into the detail of, you know, just give a simple measure, because the more detailed the measure you have, you might be going further away from what the person is really making the decision about, or what different people will make the decision in different ways, kind of thing. So there are a couple of other people who have independently come up with the same idea. So Conveil, I think you can do multiple samples easily. It's not free either. And Remix, this is an example of what Remix have done. So they're looking more into car to transit ratios. So this is one I ran for Melbourne. Remix is pretty cool though. Yeah, so that's about it. I can talk pretty quickly.
Thanks, Belinda.
No worries.
Yeah, that was great. We've got a couple of questions coming through.
Yep.
Do keep them coming everyone. So the first one was, are you considering paying for APIs in order to increase the scenarios?
I've had some epic meetings with Microsoft and Google. So I don't think, it's kind of, I'm trying to work that out at the moment. Yeah, so it sort of gets another layer of like dealing with my IT and big data people. So you can get away with a fair bit on the free trial. So I think you get $300 for a new account, and about $200 a month for free. But it's very complicated and very easy to go over the limit, and it I think it costs roughly, from memory, I think it's about $5 for 1,000 calls, or no, that can't be right. But the traffic, the driving with traffic is a bit more expensive than just driving without the traffic. So yeah, it's complicated. But yes, I am looking to, at the moment we're doing some case studies of areas that we're writing reports on anyway. So they will hopefully be small enough that I won't need to, because you can see that when you start getting into the outer reaches of Melbourne, you end up running quite a lot of points. So I think it's about 7,000 points is the most I've run in one go, but then you've got to run them multiple times for different for the different modes. So, and it can do walking and cycling as well.
Yeah, okay. Just off the back of that, I guess from my personal curiosity, how what's the sort of value of each of the API calls? Because as you can sort of ping them until the cows come home, but how much incremental value are you actually getting by more?
Oh, exactly. I mean, you're not. I'm more thinking about like if you. You just don't know whether when you're doing a PT, I mean, you probably wouldn't need to drive, probably wouldn't need to query driving a lot, because I'm assuming there's a black box algorithm that's kind of roughly estimating the driving time, and I don't know what it's doing with COVID. I haven't looked at the data I ran the other day. So, but I've just lost my train of thought. So with public transport, you might have just missed I think what it does, I haven't checked this yet, I think if you do I'm departing at 8 a.m. but a service isn't leaving until 8:15, I think it just makes it's returning the travel time rather than the arrival time. So I think it's not taking into account sort of how long you're waiting. So you might want to, you need to think about the frequencies and so with public transport, like one query isn't a definitive answer as much as driving would be.
Sure.
Yeah.
Okay, cool. Got another question here. Great talk. Can you give a little bit more about the alternative approaches to the ugly nested for loops? I definitely don't use either for managing a nested list.
Well, yes, that's I'm only just learning functional programming at the moment, so like just getting my head around the map calls that I used was epic. So yes, I mean particularly my awful for loops have because you've just got so many nests of like mode and tranche, and it's this origin, and it's it's this there's like a time and a distance as well, so you can actually calculate speeds as well. So I mean average rough speeds. So alternative is do it properly. Don't do it in like 4 nasty for loops with like crazy square brackets everywhere. And so yes, I'll tell you about that once I've done it. Yeah.
So when you say functional programming, are you sort of meaning writing a function to sort of get different nests out? Is that sort of
Yeah,
what you mean?
and
Yep.
also like the way I did it, like I was in a hurry, and so once I got it working for one mode, I just copied it and I changed the name of the mode within, because the sort of the mode name is in all of the little nested, you know, nests. And yeah, so
Sure.
it just, so that means if you change something, you don't have to change it 4 times as well. And I've broken it,
Right.
and I need I now have to find I don't know what's broken, so my friend said start again.
Yeah.
Yeah.
Cool. It's another question here on the API trips. So how do the API trips align with what you think people might choose
Sort of
at their
what?
traveling path?
Is that sort of a question about like, are a lot more people driving if the public transport access is really bad, or is it, or like, I mean, is it comparing like prediction to what we see in our data, or is it more about
Not quite sure. There's not much context there.
yeah.
Okay.
We'll wait for that person, for Reed Hot Sauce to
Yeah.
to clarify. But they also ask about using this approach as a strategic planning tool. So obviously I am a data person in a sea of planners who aren't data people. So just showing them that this can work is really important, so that they know, oh, we can actually use real data about the current network, and also about, and it's also what people are using to make their decisions. So as a strategic planning tool, I mean, I guess it's not, in a way, it's not really strategic, because it's more like current. But if you use it to say, oh well, look, maybe the reason that people aren't taking public transport here is because the options are so terrible, or the frequency is so bad, or everybody knows that bus never runs, and like we've got data on whether that bus never runs, and we've got we could potentially, I mean, if you did you wouldn't have to do it through the Google Maps API. You could look at there's open trip planners that you can run on GTFS data. GTFS is the Google Transit Feed specification, if you don't know what that is. So you can do that offline as well, sort of analyze the complexities of the way the network sort of works in practice based on the timetable. You could.
Just on that, like, how did you present your results to stakeholders?
I did so I organise a data community of practice at the Department of Transport, to try to get sort of data nerds together. It's not it's not really working because they're all introverted. They don't want to talk to each other. So I presented to that, and I've like done a presentation for the bus planners to try and show them, look, this shows you sort of on paper what might be happening in Melton. And I mean, obviously you need to factor in, like, if there's no public transport access to an area where there's no residents, that's fine. So you need to sort of integrate that as well. But yeah, so people are probably sick of getting emails from me about, updates on this project, or, sending them 14 megabyte leaflet maps. And yeah, so I just talk at anyone who'll listen, basically, and, try to find allies, I guess.
Yep. Cool. Yeah, we've got some clarification on
Yep.
that earlier question, and it's basically asking how realistic the API generated routes are.
That's a very good question. You could pull multiple options. So like you could look. I think the distance API. The directions API can do multiple options. The Microsoft one certainly can. So you could compare the different possible options, and you could look at what, I mean, we don't have very good data about what trips people actually take, but you could try to compare it to what you're seeing. But like, that's kind of like, I mean, the first thing I would like to do with this is to and I haven't had time because I've been working on other things, is to look at, well, does it make sense, and does it tell us anything useful? Yeah, so it might be interesting to look at it compared to, on top of mode share maps, or yeah. So that's yeah, what I'll be probably looking at soon. Yeah.
Cool. Do you have internal data around that? I mean, could you just validate that against your non-public data?
We have a travel survey called Vista, but I don't think it's not a very big sample size, so it doesn't really. And there's you can take journey to work data from the census. So yeah, you could definitely. The journey to work data is pretty gnarly the way it comes out of the ABS. So yeah, you could. You could validate it, but like I said before, if people are being told to go this way, like, sure, people might not go that way, but people who don't know the route would maybe take Google's advice. So yeah, I don't know the answer to that, but I think it's more of a very big picture kind of tool. So it's not necessarily, if it gets one little thing wrong, it probably doesn't matter in the scheme of things. It's more like, okay, where is the access really bad, and can we check that it really is that bad, and how can we fix it?
Yep. Yeah, that makes sense. Cool.
Mm.
Just one more question from Rachel. You mentioned curvature of the Earth was a factor to consider. How was that taken into account? And on a related question, are there options to play with different types of map projections?
Now, I asked my mapping person about this the other day, because I don't know a lot about this, but I think he said that Leaflet only does a particular projection. So what I've actually done recently is I've got him to generate hexagons for me within mapping software, and I'm going to try running those centroids and see if they look a bit better when they're mapped in Leaflet. But yeah, it might be that you actually have to map them in a proper software in order to not get that warping. But yeah, I will. Yeah, I'll have to wait and see how my latest data run went and how it maps.
Okay, cool. I hope that answers the question. We only have it seems like we don't have too many participants, so just because of that, I think if there's anyone sort of that doesn't really want to type but does still have some burning questions, please feel free to unmute yourself and ask a question. But otherwise, yeah, that's great. Thank you very much for
No worries.
your talk. And I'm also just wanted to check whether you'd be able to sort of post your slides or the code that you've generated.
Yeah, so the slides are online. The code belongs to the Department of Transport, but I mean, I can, if you email me, I can try to do a how-to, because I'm sort of I'm training my poor colleague to learn how to use my awful for loops. So I'm gonna have to clean up the code anyway. So yeah, just email me and I'll see what I can do. But yeah, I can't like post everything online. But yeah.
Sure. No, that's fair enough. That's fair enough. Cool. Yeah, looks. I think that's about it. Hopefully, there's no more questions. And yeah, lots of congratulations. I'm sure you can see the
Yeah, thank you,
the comments
everybody.
yourself.
Thanks.
Thanks again, everyone, for joining us online. And again, thank you to Belinda for that talk. That's really cool. I really like the old maps as well. I was trying to work out.
There's more even. Like I didn't even use them all.
Yeah,
Yes.
so thank you.
No
Do
worries.
keep a lookout. We'll try and run another meetup, I think, next month. We're just trying to work out what we do, whether hopefully it can be online, in person, which is not so awkward. But we'll see how things go. Otherwise, yeah, thank you. Thanks again.
Okay, thank you.